Okay, this one is our Tito 3, Tito number 3, talking about first of all, Tito from Tito 1. We got to learn how to download R. Secondly, we talk how to have data in R and also do some descriptive statistic. Then we are counting this Tito also will talk about the descriptive statistic and the explanation of some of them. Okay, we were just calculating quantile from the second part 2 video, and now we say that from here we will explain what is quantile and so on. Okay, as you can see, quantile is just used to see the rankings of numbers we have in our data. Can you see we have 0%, 25%, 50%, 75%, 100%. Okay, what's the meaning of this? When taking this variable wage, can you see how our data is? Wage is this one we are taking, and now the entire data is wage 1. Okay, and the variable here, independent variable here is wage. Then we are just calculating quantile of it, and what is the meaning? Okay, as I'm just saying, we have 0%, 25%, 50%, 75%, 100%. Okay, the meaning is like the minimum, okay, the minimum value, inside this data of which is this one, 0.53%. is for this reason we have it as 0%. Okay, the maximum is 24.98%, and 24.98. This value is the maximum value we can find in our data wage. Okay, and now we have what we are calling interquartile. Interquartile is what is among on the middle of all of the quantile. Can you see 25%, 50%, 75%? What's the meaning of this one? The meaning of 25% is meaning that when we are taking this data, 3.33 is above 50%, 25 is above 25% of all data we have under the variable wage. Okay, when we are taking 4.65, is saying that it's above 50% of data we have under the variable wage. Okay, the same thing here. When we are taking 6.888, is saying that this one is above 75% of all data we have under wage. That's the meaning of those percentile. You can see them called percentile, quartile, or interquartile things. Okay, another things I want to add is when we are taking 50%, this one also is what we are calling median. Okay, let us now use this part now to use what is median. Median is not always the mean. Okay, they are not mean the same thing. Okay, sometimes they can be the same. At the times, mean and median are the same, meaning that we have what we are calling symmetrical distribution. Okay, when you see mean equal median, we have at that moment symmetrical distribution. Okay, and what is now median? Median is saying that the number you have under median, this number is above 50% of the data, and also this number is below 50% of the data, is at the middle. Okay, that's the meaning of the median. Okay, but mean, as I was saying, mean is the average, taking everything together and sum them and divide by the number. That's the difference between median and mean. And let us calculate our median. Okay, from here also to calculate our median is just to do that using the name, and now the data wage one, now $sign, and now taking this one, you can see I have to calculate its median. Okay, I have 4.65. Okay, let us now repeat calculating mean, and you will see that they will be different in that case. Mean now, and having wage one, and from wage one now, we can have this one and calculate, and you will see that the median is 4.65 and the mean is 5.89 here, around here. So what is happening with median and median and mean? Here's meaning that what I can even now say that it is I don't have what I'm calling symmetrical distribution because they are not the same. Okay. Okay, let me also add something also. You have already understand talking about normal distribution. Okay. For our next videos, we will get chance to know more what is normal distribution. But when median and mean are closer, we can suspect, we can say that our data is likely to be normal. Okay, when median and mean are closer. But what is happening is when mean and median are the same, we have symmetrical distribution, which is also a normal distribution, but symmetrical distribution is the highest level of the normal distribution. Okay, perfect normal distribution is called symmetrical distribution. What is happening? Okay, then we are still with our statistic descriptive, and we calculate now median, we calculate mean, standard deviation also we calculate, and so on. That is okay. Next thing, next things we need to do. Let me use this one. You will see what it will give us. The bill. Yeah. Which one? Okay. The bill I can use, as I'm just telling you what is happening sometimes when you get error when you are calculating or doing something from it's not for forcefully that you use something is wrong, but maybe the package inside we should be around before to use it is not yet just around. That's the problem. And also the way also we are running some things around here depends on also the package we are using. Each package has its specification, how to use it. Okay, normally I should now download this package Tabil. Okay, I was just using Tabil. You can see Tabil and table are like the same. Table is giving us only frequencies, but if you want to have also percentages, you can use Tabil. But I need a specific package before to do that. That was also another part of the 630 when we want to use percentages and frequencies and so on. Okay, then what is also important, very important to understand and to know is the normal distribution. What is the normal distribution? And because this normal distribution is under many, well, it's one of the conditions which should be respected. Mostly when we are doing some tests, when we are doing even some regression and so on. Then from the next video tutorial 4, I think, we will just talking about normal distribution, how to understand really what's normal distribution, and how also to check from your data how what is how your data is, are they normal distributed or not, and so on. Okay, then let us stop from here, and you need to watch the next video, part 4, and see what about normal distribution. Thank you for your time.